We're about to pull back the curtain on a technology that you've definitely used today, but I bet you've never even heard of it. It's an invisible process that's the secret sauce behind some of our most advanced, mind-bending innovations. So let's dive into the amazing world of electroless plating. Okay, so let's start with a bit of a riddle. What on earth could a microchip, a medical implant, and a piece of smart fabric possibly have in common? I mean, at first glance, they seem like they're from completely different universes, right? Just think about it for a second. You've got these ridiculously complex 3D circuits that are the literal brains of our digital world. Then you have these super soft, flexible medical sensors that can move with the human body. And then get this, you have fabrics that can actively kill germs on contact. So what's the link? The answer is actually really simple, but it is a total game changer.
And here it is. The one thing that connects all of them is an incredibly precise layer of metal. But here's the twist. It's applied using a process that requires zero electricity. It's a perfect, powerless metal coating, and it's what makes all that other cool tech possible.
So, let's get right into it. We're talking plating without the zap. We're going to break down the magic behind this whole process, and you'll see pretty quickly that it's nothing like what you probably picture when you hear the word plating. So, what is electroless plating, really? Well, put simply, it's a chemical trick. You dip something into a special solution, and a layer of metal just deposits itself onto the surface. The most important word here is electroless. No power cords, no zap. The coating literally grows all by itself, atom by atom. It's kind of wild. And to really get why this is such a huge deal, you have to compare it to the old way, traditional electroplating. Think of that like spray painting. You need power, it's tough to get an even coat in all the nooks and crannies, and it really only works on stuff that conducts electricity. Electroless plating, on the other hand, is more like dipping something into a magic potion and watching a flawless metal skin grow over every single surface, inside and out. And that's its superpower. It can coat pretty much anything, plastics, ceramics, you name it.
The process itself is surprisingly elegant. First, you prep the surface of the object to make it kind of sticky for metal ions. Second, you just immerse it in a chemical bath that's full of dissolved metal. And then, step 3 is where the magic happens. A chemical reaction kicks off all by itself, and the metal starts to grow in a perfectly even layer across the entire surface. It's like watching a crystal form, a beautiful, controlled chemical dance.
So now that we get the how, let's go on a little tour and see the what. We're going to look at where this invisible process is quietly changing literally everything. This is the hidden architecture behind so much of our modern world.
Let's start with electronics. And let me be clear, in this field, it's not just useful, it is absolutely essential. You want to build those complex 3D pathways inside today's microchips? You have to be able to coat the inside of tiny, deep tunnels. Well, that's electroless plating. You need to create reliable connections between different chip layers, draw conductive lines on flexible circuits, or get this, turn a 3D printed piece of plastic into a working electronic part. Yep, this is the tech that makes all of that happen.
And the precision we're talking about here is just staggering. To give you a sense of scale, this process can create a flawless, uniform metal coating inside holes that are smaller than 1 micrometer in diameter. That's less than the width of a single bacterium. It's that kind of insane detail that lets our technology get smaller and more powerful every single year.
The impact it's having on medicine is just as profound. We're talking about applying safe, biocompatible coatings to medical implants so your body doesn't reject them. It's what allows for soft, flexible EEG electrodes that are gentle enough to be used on infants. It's how they get that antimicrobial silver into hospital fabrics. And in maybe the most incredible application of all, researchers have used it to build a working glucose sensor on a single strand of human hair. A hair! And that's really the heart of it, isn't it? The ability to perfectly coat any shape, no matter how complex, with materials that are safe for the human body. That is a cornerstone of modern medicine. It's letting us merge technology and biology in ways that just were not possible before.
And the list of applications just keeps on growing. In energy, it's being used to create more efficient catalysts for things like hydrogen fuel cells and to build better parts for next-gen batteries. And textiles? This is what brings smart fabrics to life. It's how you get durable, washable circuits for wearable tech. It can also achieve these incredibly dense silver coatings covering over 56% of a fabric surface for some seriously powerful germ protection.
Okay, so that brings us to the future.
Because as powerful as this all is today, innovators are pushing the boundaries even further. They're looking at nature, they're using lasers, and they're focusing on sustainability to completely redefine what's possible.
One of the most fascinating new frontiers is something called bio-inspired plating. Researchers are literally looking at nature's own building blocks, things like proteins, to control and guide how these metal layers form, especially on really tricky surfaces like flexible plastics.
So how does that even work? Well, in one method, scientists are using a protein called bovine serum albumin, or BSA, as a sort of molecular primer. It helps the metal stick incredibly strongly to flexible materials, which gives us much more robust wearable sensors. They're also taking inspiration from the super sticky proteins that mussels use to cling to rocks, creating a synthetic version that helps make these perfectly uniform silver coatings on fabrics.
The next major leap is all about control, achieving precision on demand. So instead of coating an entire object, what if you could just draw a metal circuit exactly where you wanted it? Well, new techniques using light are making this a reality.
This process is genuinely mind-blowing. It's called laser-activated plating. Here's how it works. First, you 3D print an object from a special plastic that has a dormant catalyst mixed right into it. Then, a precision laser draws the exact circuit path you want right on the surface, which wakes up the catalyst only along that line. Finally, when you dip the object in the plating bath, the metal grows only on the laser-drawn path. You're basically printing custom 3D electronics on demand.
Of course, with any powerful industrial process, sustainability is absolutely crucial. And the good news is, Electroless plating is making huge strides here. Researchers are developing safer chemical baths that don't use hazardous stuff like formaldehyde. They've designed systems that can recover over 94% of valuable nickel from wastewater, and, in a perfect example of a circular economy, they're now turning that recovered plating waste into high-performance materials for new sodium-ion batteries. How smart is that?
So let's bring it all together and just look at the big picture, our invisible plated world. Now that we've seen the how and the where, let's really lock in why this hidden process is so foundational for our future. So what are the big ideas to take away? First, it's sheer versatility. It can coat almost anything. Second, it's incredible precision, allowing us to build at the nanoscale. Third, it's a powerful engine for innovation, driving everything from flexible electronics to clean energy. And finally, all of this makes it a true foundational technology. It may be invisible, but it is absolutely essential to the world we're building.
And that leaves us with a final thought. This technology gives us the power to add a functional, perfect layer of metal to nearly any object we can create. So as we continue to master this process, the real question isn't just what can we make, but what kind of future will we choose to build with it, one perfect atom layer at a time.